Okay, this lesson is on coterminal angles, arc length, and linear and angular speed. Coterminal angles are angles that end at the same position. So if I start here and rotate up 70 degrees, I'm right here. Or if I start right here and I rotate down negative 290 degrees, I'm going to stop at the same position, even though they're two different angles. Those are coterminal angles. Or if it's negative, you can add a full circle to it to get a coterminal angle. Now, they want the answers to be less than 360 degrees, but still be positive. So sometimes when you use this technique of, okay, if it's positive, we subtract a whole circle, we're still not in the correct margin of our answer because they want it between 0 and 360. So we may have to subtract a full circle again until we get the answer in the appropriate margin. All right, with radians, it's a little trickier. With, again, a positive radian, we're going to subtract a full circle. We convert 2 to 5 or 10/5 and subtract. With negatives, again, we're going to add a whole circle if it's negative. 2 is the same as 30/15 and add. Here, if it's positive, we're going to subtract a full circle. 2 is the same as 12/6 and subtract. And then this one took a while because we had to keep adding full circles to get there. So we took our negative 25/6, added 2 pi, which is 12/6, got a negative answer. That's not going to work. Our answer has to be positive. We did it again, got a negative answer again. No, an answer has to be positive. Did it one more time, and finally got an answer that's between 0 and 2 pi, because 12/6 would be 2 pi. This is just under that. Arc length. Arc length is just a matter of how far you're going on the outside of a circle. So just this little section of the circle would be a length. Before we had a formula that said that the radians of the angle measures the arc equals the arc divided by the radius. So it's basically the same formula. Arc is S and radius is R. I just multiplied on both sides by R. So you can see that the arc length is equal to the radius times the radians. Now here in this example, I'm just substituting 6 for the radius. However, for the angle, they gave it to us in degrees. That's a problem. We can't use it in degrees. See the formula? It says it specifically has to be in radians. So I changed 45 degrees using my unit conversion fraction here down into pi over 4. And then I use pi over 4 to find my answer. The next thing we're going to talk about is linear and angular speed. Linear speed is how fast you're going in a straight line. Angular speed is how fast you're going in a circle. So if you're talking about driving in your car at something or other miles per hour, your wheels may be spinning at 80 revolutions per minute or per second. That's the difference. So the wheels would be moving in a angular speed, and your car is moving in a linear speed. Anyway, here's the formula for linear speed. I can see there that it says find the linear speed. Now, with this question, simply want to work backwards from the answer. So, what I mean by that is first I figure out what they're asking for, linear speed, and then I write down the formula for that. W is angular speed, by the way. Okay? And then I say, okay, how do you want your answer? Well, they want their answer in inches per minute. So I just take all my pieces and I plop them in. The radius they're telling me is 1.5. They're telling me the angular speed, right here it says angular speed of 45 revolutions per minute. So I put that there. Now, if I multiply these together and I want the answer to be in inches per minute, basically I know that I have to cancel the revolutions. This is 45 revolutions. And I have to figure out how to do that. Now, this is 1 radian, right? 1.5 inches equals 1 radian on this record player. So I wrote that kind of together as an equivalency. 1.5 inches equals 1 radian. Now the reason why I did that is that we can cancel revolutions and radians because those two have an equivalence. 2 pi radians equals 1 revolution. So the reason why I put the 2 pi radians is on the top here is that I can cancel the 1 radian here. And the 1 revolution down here cancels with the revolutions there. So If I multiply straight across the top, I get 135 pi inches per minute, or if you want to approximate that answer, it would be 424.1 inches per minute.